Hello everyone, my name is Sagar. I was part of the person who runs the planet. I'm here to invite Professor Dr. Mojib Latif. He did his diploma in meteorology in 1983 and PhD in oceanography from Hamburg University. He is professor at Holtzman Center for Ocean Research Kiel since 2012. He has been contributing author for IPCC reports in 2001 and 2007. He is the present member of CAU Cluster of Excellence, the Future of Ocean, and he is also the chairman of German Climate Consortium. He has been awarded with several awards, including LC Choice Award, which is the Atmospheric Science Librarian International. It is an award for the best book of 2012 in the field of meteorology, climatology, and atmospheric sciences. So, allow me to invite Dr. Latif to talk on humankind and the stability of the Earth system.
Yeah, thank you very much for inviting me to this really exciting meeting here at this beautiful lake. I hope you will enjoy this meeting, and I have to apologize. Unfortunately, I have to leave tonight already because I need to be in Kiel at the university tomorrow morning. So I think the climate scientists have not really much doubt anymore about that humankind is influencing the climate of the planet, and therefore also the conditions on this planet in total. And I just have one short quote here from the last IPCC report. IPCC is the Intergovernmental Panel on Climate Change. So this is a board of several hundreds of climate scientists who come together and publish the state of the art in climate sciences every 5, 6, or 7 years. And from the last report here, just this very brief sentence: human influence on the climate system is clear, full stop. So in principle, one doesn't really need to know much more as a politician. Okay. However, and I will show you this in a minute, politicians are aware of the fact that we as a mankind are influencing climate, but they are unable to cope with this challenge and run from conference to conference without much success. Now, what is the problem? The problem actually is the way of producing energy on this planet. So we see here the Earth at night from space, and as you can see, there is a lot of light. And light is energy, just an example of energy, and basically the global economy depends on the availability of energy. However, the use of energy is very unevenly distributed. Okay, so you see here, for instance, that in the industrialized world, so in countries and in European countries, you see a lot of light. Okay, which means that these countries need and produce a lot of energy. On the other hand, if you look at Africa, Africa is the darker continent, and there is not much energy produced on that continent, and therefore I think this picture also tells us something about responsibility. It's basically the industrialized world which has the responsibility for the climate change problem. Now, but why is the way we produce energy a problem? All right. So more than 90%, more than 90% of the energy that is produced on this planet is produced by burning fossil fuels. Okay, so fossil fuels are coal, oil, and natural gas. Okay, and more than 90% of the energy that we produce as a mankind is basically done by burning the fossil fuels. And these smoking chimneys here are basically a synonym for this burning of fossil fuels. However, although we see all this smoke, we don't really see the reason for the climate change problem, because we can't see the reason or the cause of global warming. Because when we burn coal, for instance, we also produce a gas, and we call this gas carbon dioxide. And you can't see gases. They are invisible, okay? And this is part of the problem. Suppose you could see gas. You could see carbon dioxide. And suppose it is red. And the sky would slightly turn red. Okay, then everybody would know, hey, we have a problem here on this planet. Okay, so this is not happening. And therefore we don't realize that something unbelievable is happening on this planet. And what is happening is that the concentration, the content of carbon dioxide, of this gas that we produce by burning fossil fuels, is continuously increasing. Okay, here is the latest figure. So we have reached the level of 400 parts per million. Okay, so we started off with 280 parts per million. So this was the value at the start of the industrialization. All right, and so we have increased by our activities, by the way we produce energy, the carbon dioxide concentration by more than 30%. Okay. But as I have said, we don't realize that this is actually happening. And I said this is unbelievable. This high concentration is unbelievable because if we compare the current level of carbon dioxide with the carbon dioxide contents during the last 800,000 years, it is unprecedented. So the current level of carbon dioxide in the atmosphere, in the air, has never been as high in the last 800,000 years as today. Now the green curve is the carbon dioxide in the last 800,000 years. And you see it has always fluctuated within a certain range. However, the current level, is outside this diagram. Where the big green arrow is pointing to. So this is the current level of carbon dioxide. And this is what I mean by if I say it is unbelievable how high the current carbon dioxide level is already. Now, some of you may ask yourself, how do I know this? So I'm talking about 800,000 years. So how can this guy, he looks old, I know. How can this guy know the carbon dioxide concentration 800,000 years ago or 200,000 years ago? Now, this is not that difficult. Okay, so we can go to Antarctica and we can drill in the ice sheet. Okay, and then we get such ice cores, how we call them. Okay, and within these ice cores, there are little air bubbles trapped. Okay, and you can analyze these air bubbles, and you can also time these air bubbles, and then you know relatively easily how the concentration, how the composition of the Earth's atmosphere has been during the last several 100,000 years. Okay, so that we have reached record values of carbon dioxide in the atmosphere is a hard fact. All right. The same is true for the red curve. The red curve is methane. So methane has different origins, okay, but it's also a gas that warms the atmosphere, that prompts global warming. And also there, you see that the current level, which is where the big red arrow points to, is also unprecedented. So it means since we, as human beings, live on this planet, the concentration of these greenhouse gases, how we call them, has never been that high. Okay. Now, we wonder about this what this means to the climate of the planet. And this person here, Roger Rubel, did this more than 50 years ago. And in an interview that he gave to the New York Times in 1957, he said this remarkable sentence. He said, human beings are now carrying out a large-scale geophysical experiment of a kind that could not have been happened in the past, nor be reproduced in the future. So Roger Revelle was actually the person who implemented these measurements. Okay, so at this time, so more than 50 years ago, there have been quite some scientists who didn't believe that when we burn coal, for instance, that the concentration of carbon dioxide in the atmosphere will increase. Okay, and this is the reason why he wanted to have measurements, direct measurements of carbon dioxide, and he eventually succeeded to implement this station on the volcano Mauna Loa on Big Island, Hawaii. Okay, so he said this sentence, and think about this sentence. So he's saying, or he said at that point, we are carrying out an experiment with our planet. And I would like to stress this. Indeed, we are carrying out an experiment with our planet, because in the end, and that's important, in the end, we don't exactly know what will happen. This is like, driving in dense fog without seeing much, okay, at high speed in a car. And you don't know whether it's the wall or not, because you can't see anything. Okay, so this is the situation in which we are. And this is completely against our daily life. So in our daily life, we try to avoid any risk. May it be even very small. Okay? So we try avoiding any risk. If we want to cross the street, okay, you look to the left and to the right, okay, and if the chances are, say, 50-50 that you're hit by a car, we don't cross the street. Okay? Or if you board an aircraft, suppose you board an aircraft, okay, you go through the checkway, and at the end, before you board the aircraft, there's a sign. Attention. This aircraft crashes with a probability of 10%. Okay, so who would board that aircraft? No one. Okay, so I'm saying this because, I'm asked again and again by politicians, for instance, are you now really sure? Are you sure by 100%, okay, that such, event or another event will really happen, or that the frequency of these events will increase? And there will be never such thing that 100%. This would be absolutely unscientific. Okay? So all we are dealing with is probabilities. Okay? But I think the probability is relatively high that we are following a wrong way. And if the probability is high that we are following a wrong path, I think it's time to turn around and to leave that path. Now, there are some tipping elements, as we say, which may occur at different times as global warming proceeds. Okay, I don't really want to go into all of these. You know them probably. Maybe we have some more talks about these tipping elements or tipping points. Let me just name a few of them. Okay, so the blue ones have to do with the ice masses, with the continental ice sheets primarily. Okay, for instance, the Greenland ice sheet. So the Greenland ice sheet has an amount of ice. If that would melt completely, sea level would rise in the global average by 7 meters. Okay, and we know that at some point, if we cross some warming, we can't avoid anymore that this will happen. Okay, it will not happen within 1 year or 10 years or 100 years, but it will happen. So we won't be able to stop it anymore. So this is what we mean by tipping points or tipping elements. Okay? Now, another thing, if some people from you come from the US, southwestern United States. Okay, and mentioning this because I don't know if you have followed the news during the last several months or so, okay, but the governor of California, and California is a state which is suffering from a decade-long severe drought. Okay, so the governor of California said that, so an American politician said, you know, global warming is not a joke, okay, because this is happening in California. It's not happening, you know, somewhere, okay, and so we have not to care about it, right? Because it's far away. No, it's happening at the front door, okay? And as I said, there are many, many more things. So the Indian summer monsoon could be endangered, and also the Western Arctic ice sheet, and so on. So there are many, many risks which we basically are actually favoring. Okay, I'm not saying that they will happen, but they may happen, and the probability that they happen will increase as the temperature of the planet increases. Now, I said we emit carbon dioxide, and it's interesting to look for a minute at the fate of the carbon dioxide. What's happening with the carbon dioxide? So you see on the left, more than 90% of the carbon dioxide that we blow into the air stems from the burning of fossil fuels. Okay, and the rest is what we call land use change. Okay, now about half of it, that's the right-hand side. So where does it go? About half of it stays in the atmosphere. Okay, this causes the increase in carbon dioxide concentration, and as I will show shortly, this prompts global. Now the rest is taken up by the vegetation, because plants love actually carbon dioxide. Okay, and so they take up some of it. And about 1/4 is taken up by the oceans, and that's a major problem. Okay, which has become obvious during the last few years. Okay, and so I will also talk about the consequences of the uptake of carbon dioxide by the oceans. So, but let us start with global warming. So, why does carbon dioxide produce global warming? Okay, and this is due to what we call the greenhouse effect. Now, the greenhouse effect is a natural effect, and it guarantees the mild conditions on this planet. So just consider for a second, you know, our two neighbors in our solar system. So one neighbor is Venus. The temperature on the surface of Venus is above 400 degrees. Above 400 degrees. Extremely hot. Okay? So that's not very favorable for life. Let's take our other neighbor, Mars. Mars is extremely cold. Temperatures well below freezing point. Okay? That's not favorable for life either. Only the planet Earth has favorable conditions for life. Has a temperature averaged over the whole surface on the order of 14 to 15 degrees C. Okay? Now the reason why that is has to do with the greenhouse effect. So Venus has an extremely strong greenhouse effect because it has so much greenhouse gases like carbon dioxide in the atmosphere, okay, that produces a giant greenhouse effect, and therefore temperatures are so high on Venus. On the other hand, Mars doesn't have much of an atmosphere and doesn't have much of greenhouse gases, and therefore it doesn't have much of a greenhouse effect, and therefore it is bitter cold on Mars. Okay, and only we on this planet have the right amount of greenhouse gases in the atmosphere. We have the right amount of carbon dioxide. Okay, so carbon dioxide is good. We need carbon dioxide. Okay, because it warms the planet and plants the carbon dioxide. But you know, it's like a medicine. Medicine can be very helpful, but if you take too much of that medicine, you know, this can prompt side effects. And this is the same situation. So the greenhouse effect is great, okay, but it must be moderate. Too much of greenhouse gases, too much of carbon dioxide, too much of the greenhouse effect actually changes the climate in a way which makes this planet less favorable for life. Now, everything I'm telling you is old. So the greenhouse effect, you know, has been described by this guy here, 1906. Svante Arrhenius was one of the great scientists of that time. He received the Nobel Prize at some point. Okay? So he was really a big shot in science. And he published a paper in 1896 entitled On the Influence of Carbonic Acid in the Air upon the Temperature of the Ground. Now, at that time, they didn't talk about carbon dioxide, they said carbonic acid. Okay, but they meant carbon dioxide. So if you read the paper, then you see it's written CO2. Okay, so if you translate this into the current language, then it means on the influence of carbon dioxide upon the temperature of the ground. So exactly the climate change problem, the problem of global warming. And he did calculations. He computed what would happen if we change the content of carbon dioxide in the atmosphere. Okay, so here are all these calculations, so don't forget. So the first thing I tell my students, never show tables. Okay, and I don't discuss it. I scan it only because it is so nice. It looks so nice, so old. Okay. But I tell you what the main message here is. So he computed what would happen if the carbon dioxide concentration in the atmosphere would double. And then he calculated a temperature increase on the order of 5 degrees globally. Okay? Now, if you take the best models today, okay, so remember, 1896, so there was not such thing as a computer or satellites, you know, not more. So he did it just with. Now, the best computer models today talk about 3 degrees. And this is absolutely fantastic. So this guy, you know, within a factor of 2, actually computed the right, in quotes, the right solution. Okay, so what I'm trying to say here is, you know, we are knowing about this problem for decades, for more than a century, and we ignore it. Okay? And therefore, I count on you guys here. Okay, so we can't ignore this problem anymore. Okay, we need to do something. Now, in a way, he made a prediction, and we can verify this prediction. So we can ask, did the temperature of the planet really rise? Because we know the carbon dioxide concentration rose. And yes, in fact, it did rise. Okay, so it's very clear, and I quoted the IPCC at the very beginning of this talk. You know, they say the human influence on climate is clear. And this is another way of showing this. Now, this has consequences. The ice of the planet is melting. So here is one example, the Arctic sea ice. Okay, so since we have satellites in space, we can overview nicely the ice, because we can see it, we can measure the extent, the ice extent, so the area that is covered by ice, and you see that during the last 30 to 40 years there is a rapid decline in Arctic sea ice. So here you have two satellite pictures, okay, one from the beginning of the satellite measurements from 1979, so most of you guys have not been even born then, okay, and one from the last year, so both from September, okay, September 2014, September 1979. And this colored area, this is the sea ice. Okay, and you see, you know, by how much the sea ice has already shrunk, right, in response to Arctic warming. And the Arctic actually is the region in the world which warms fastest. And this doesn't come as a surprise, because even Svante said this in his paper in 1896, that if there is a region on this planet that would warm fastest, it would be the Arctic. Okay? So, if the sea ice melts, sea level doesn't rise, because this is ice which is already in the water. However, if ice melts that sits on land, that we call land ice, okay, then sea level will rise. And we see, without going into details, so Greenland has a big ice sheet, okay, so we see huge mass losses in the Greenland ice sheet. So here you see the satellite data, so this is a relatively short record, which is a little bit longer than 10 years, but you see clearly the tendency. So the Greenland ice sheet is losing mass. The same is true for the Antarctic ice sheet. So where does the water go? The water has to go somewhere. It goes into the ocean. And this produces sea level rise. And so we can look at sea level. And what we see during the last 130 years or 140 years is, yes, sea level is rising. Okay? And sea level rise is slowly accelerating because the ice melt is accelerating. And we are talking here about 20 centimeters since 1870. But the interesting, or not necessarily interesting, but one thing that can become really dangerous is that although sea level is rising on the global average, so here again, during the last 20 years, it is regionally extremely variable. So not every region on this planet features the same sea level rise. Okay? So here we see the sea level rise during the last 20 years or 25 years. Okay? And you see there are areas on this planet where sea level rise is faster than the global average. But there are also regions where sea level rise is slower than the global average. And the region where sea level rise is the fastest is the Western Tropical Pacific. And you know, this is the home of many island states. Okay? So here, at the current rate of sea level rise is about 1 centimeter per year. 1 centimeter per year. So if this tendency will continue, okay, then in a time span of 10 years, sea level will rise by 10 centimeters. Okay? And these countries are really in danger. I don't know if this is due to a natural fluctuation or whether it is part of the response of the climate to enhance greenhouse gases. So the models don't show a unique response. But we can conclude that sea level rise in the Western Pacific and also in the Indian Ocean will be faster than in any other region of the world. And so those countries will be punished twice because they suffer from the sea level rise, and secondly, they are responsible for the sea level rise. Okay, so there's a lot of injustice in this climate problem. And then, which is important, there is the other climate problem. I told you that not all of the carbon dioxide remains in the atmosphere. About a quarter of the carbon dioxide that we emit is taken up by the oceans. And this leads to acidification. So the oceans become more acidic. And there are many creatures, like corals, tropical corals, or little crabs, snails, and so on, which must calcify, as we say. Okay? So they produce calcium. And as the water gets more acidic, they can't really do that in a way they normally do it. And so they may extremely suffer not only from the warming, but also from the acidification. And we can measure the acidification, so don't look too much at this figure here. But all colors you see mean that the oceans in that region have become more acidic. No matter whether you look at green or yellow or orange, all oceans are getting more acidic. Okay, and this cannot be good. So there is another problem, okay, which is independent of global warming itself. It's a pure CO2 problem. If we emit CO2 in the atmosphere, independent of whether the planet warms or not, a part of that is taken up by the oceans, and this must lead to ocean acidification. And we can look at small creatures which you can't really see by eye, only on the microscope, and you see, if you expose them to enhanced levels of carbon dioxide, then you see, how the structures become unsmooth in comparison to how they look today. Okay, and they are basically at the beginning of the food chain. So we are talking also here not only about climate, we are not only talking about ocean acidification, we are also talking about how we can feed the human beings in the future. Because if the food source of the oceans will collapse, okay, we have another major problem here on this planet. Now, I think one point I would like to make here, and that's really important, is that we still have the choice. Okay? So, and I'm saying this because this means it is worse to fight, actually, right? And I'm doing this, like Fritjof, for many decades now, and we will never give up, okay? And I think my wish to you is, never give up. Even if you think the situation is, or that the problem can't be resolved, never give up. There's always a possibility, okay? And our climate models do show that it is not too late. So if we really act rapidly, if we decrease the output of greenhouse gases in the atmosphere, then we can actually stay below the 2-degree limit. 2 degrees global warming is a limit where we believe that we don't really kick off these tipping elements. So which world do we want? So here are two simulations. On the left, the best case. Okay, so if we take all measures to reduce greenhouse gases or greenhouse gas emissions, and the right planet is the worst case. Okay, and I think so. Now we are heading toward the end of the century. I think you get some feeling, how different the evolutions on these two planets is. All right, and I think we definitely don't want the right planet. Okay, so this is the planet, business as usual. We don't do anything. Okay, and the politicians will never agree on anything. But on the other hand, you see the left planet will be still a planet which maintains a relatively mild climate, and therefore it is a challenge, yes, a big challenge, but it is possible. I think that's the point, okay? So therefore never give up, it's possible. Now acidification, I have also a movie here. There is this red arrow, okay, and we should not drop below this red arrow in terms of the pH value, so the acidity of the ocean. And you see, if we continue, as we did during the last decades, we will cross this threshold by the middle of the century, okay? And so, once again, even if global warming won't happen, this problem is a severe problem, and we can't avoid this as long as we emit carbon dioxide. So there are many, many good reasons to avoid producing carbon dioxide and to let it escape into the atmosphere. Now, last point, where do we stand with regard to the international climate negotiations? Okay, you guys will do your act here in Elmau when the leaders of the world get together in June. Now we have every year a climate conference, a World Climate Conference. So the last was in Lima, COP20, Conference of the Parties 20. Okay, so this was last year. The first climate conference in Paris. Okay, and everybody is looking to Paris. Okay, and the politicians promise, this will be basically the turnaround. So now we will have a protocol, and now we start saving the planet. However, I heard this too often. I myself attended a summit in 2007, which also was in Germany, in Heiligendamm. Okay, and I just let you know the statement. And this was the statement by which the German Chancellor, Angela Merkel, became the climate chancellor. Do you know what the statement was? We, so George Bush, Angela Merkel and company, we seriously consider to cut carbon dioxide emissions by 50% by 2050. We seriously consider. This is a null bit information. Because, suppose you want some money, you go to a bank and you want some money. And you say, I seriously consider to return the money. You will be thrown out immediately. Okay, so this is the level of agreement that resides on these conferences. So what happened during the past decade, since these people meet every year on these climate conferences, is that the carbon dioxide emissions, so the output of carbon dioxide, increased by 60%. 60%, 60. Okay. And remember my words, when you hear the words in December in Paris, when they will talk about big successes and major breakthroughs. Okay, remember my words. So the black curve is actually the increase or the emissions of carbon dioxide since 1980. Now there are different scenarios here. You can pick your most favorable, but in principle we are on the red scenario. So this is the worst case, and this will mean in the end a global warming on the order of 3 to 5 degrees by the end of the century. But you see also that the blue curve is not so far away from the black curve. Okay, so this is once again, my pledge. It's not too late. So if you really want it, we could jump on this blue curve. All right. What makes it so difficult? And there is something that we call gray emissions. What does this mean? Everybody's looking at China. So China, this is the emissions of different countries, or groups of countries. So this magenta curve is China. You see, China has now become the biggest producer of carbon dioxide. And everybody's looking at China, okay? And everybody's saying, hey, you Chinese guys, you have really to do something. But this is unfair. Why is this unfair? Because the Chinese people, they produce also for us. Okay? So, and the carbon dioxide is produced there, and no longer here. So we haven't gained anything by that. Okay? And therefore it's unfair to accuse countries like China, or Indonesia, or other countries who are slowly developing. So that's point number one. Point number two has to do with the historical responsibility. What do I mean by that? If we ask who put the carbon dioxide into the atmosphere that we measure there now, okay, these 400 ppm, where did it come from? Then you have to look at the integral emissions, at the cumulative emissions. So the emissions summed up over many decades, because what my parents produced and what my grandparents produced is still up there, because it has a residence time of about 100 years in the atmosphere. Now, and this is basically the responsibility. The countries like China are just beginning to produce carbon dioxide, but countries like the United States are doing this for many, many decades. Likewise, Germany. Okay, so you can compute by scientific means the responsibility. And so more than 1/4, more than 25% of the carbon dioxide that we measure in the atmosphere is from America. Another quarter, another 25% is from Europe. So this is more than 50%. Okay? Now if you count the share of China, it's on the order of 12%. Okay? So 12%. So you can't blame China and other countries like in
the science behind all these things. On behalf of the Youth Summit 2015, we have some token of appreciation to Dr. Latif. Please give a round of applause.